નહીં હાથ કાઢે ને આમાં એટલે બધું હરખું કરી લે છે.
Honorable Vice Chancellor of Junagadh Agriculture University and President of today's function, respected Dr. V.P. Chotia sir, Principal of College of Agriculture and Chairman of today's function, Dr. K. Ekman sir, Director of Central Institute of Agricultural Engineering and Guest of Honor of today's function, Dr. C.R. Mehta sir, Registrar of our University and co-PI of IDP project, Dr. P.M. Chauhan sir, our Director of Extension Education, Dr. H.M. Gajipra sir, Principal and Dean of Agriculture Engineering College, Dr. N.K. Gotia sir, Principal and Dean of Veterinary College, Dr. P.H. Stark sir, our Director of Students Welfare, Dr. V.R. Malam sir, Associate Director of Research, Dr. P. Manoj sir, Head of the Farm Engineering Department and Organizing Secretary of this webinar, Dr. Rajvi Yadav sir, Co-organizing Secretary of this webinar, Professor V.R. Vagaria and Professor B.V. Chavda, other delegates, experts and head of departments of this university, faculty members, staff members and my dear friends. A very good morning to all of you. Today we have gathered here on the occasion of inaugural function of the webinar on status and strategies for farm mechanization in India, which is organized by Department of Farm Engineering, College of Agriculture, Junagadh Agricultural City, Junagadh. As we all know that the agriculture mechanization is an important input to agriculture for performing timely farm operations, reducing the cost of operation, maximizing the utilization efficiency of costly inputs, improving the quality of produce, reducing the drudgery in farm operations, improving the productivity of land and labor, and for improving the dignity of labor. Looking to the importance of farm mechanization in agriculture, today's webinar is organized to discuss the strategies for increasing the utilization of machinery in farm operations. Now, in the beginning, I will request the Head of Farm Engineering Department and Organizing Secretary of this webinar, Dr. Rajvi Yadav sir, to welcome the guest by words. Dr. Rajvi Yadav.
Good morning to all of you. It's my great pleasure to invite all of you, especially Honorable Vice Chancellor and President of today's webinar, Dr. V.P. Chotia ji, Chief Guest of this webinar, Dr. C.R. Mehta, Director CIAE, Central Institute of Agriculture Engineering, Bhopal. Dr. A. Khoot, Principal, College of Agriculture and COPI IDP and Principal ABM. Dr. P.M. Chauhan, Registrar, JAU Junagadh and COPI IDP. Dr. H.M. Gajipara, Director of Extension. Dr. V.R. Malam, Director of Student Welfare. Dr. P. Mohanot, ADR and Nodal Officer, ICR. All HODs, research scientists, and Dr. N.K. Gotia, Principal, College of Agriculture, Engineering and Technology, and Dr. P.S. Stark, Principal, Veterinary College. All staff members present here on this one-day webinar on status and strategies for farm mechanization in India on behalf of Farm Engineering Department. Indian agriculture is a diverse and capable of producing almost food grains including horticultural crops in India. India producing wheat, rice, sugarcane, fruit, and deserve good position in world ranking. There is direct relationship in farm mechanization and crop productivity, which saves inputs like seeds, fertilizer, labor requirement, and time of operation. Farm mechanization also helps in increasing the efficiency of agricultural labor and reducing labor and workload. It also aids in improving the harvest and reducing post-harvest losses. Such benefits help the farmers to reduce production cost and earn extra income. Advanced farm mechanization can improve the lives of farmers and agricultural workers. Digital agriculture, where farmers can use digital technologies to assess useful information, particularly on weather. Key vendors in farm mechanization market are tractors, including the mini tractors, harvesters, combine reaper, binder, reaper, power tiller, rice transplanter, laser land leveler, and vegetable transplanters. National Innovation Foundation NIF Ahmedabad is also helping to small manufacturers and farmers to making different farm equipment and introducing a new concept of community workshop on which farmers can work jointly for their manufacturing work as well as repair work of farm equipments and machines. The government initiations towards farm mechanization aims at increasing the acceptance, adoption of mechanized farming in the entire country. The farm size and area under cultivation will remain constant. Hence, productivity enhancement within the constant land area will be critical in future. This signifies that agricultural will need a massive infusion of technology for efficient farming will be important in days to come. Today, Dr. C.R. Mehta, Director CIA Bhopal, will talk on trend in mechanization of Indian agriculture in morning hours, and in afternoon hours, Dr. Niranjan Prasad, Head Processing Product Development Division, Institute of Natural Resins and Gums, Ranchi, will talk on mechanization of log production and primary processing and overview. I hope both the talks will be helpful to the participant and staff members too. Finally, I welcome to all for today's webinar. Thanks.
Thank you, Yadav sir. Now, as per our Indian tradition, we shall inaugurate the function by lighting the lamp. And to complete this formality, I would request our Honorable Vice Chancellor and President of today's function, Dr. V.P. Chotia sir, to lighting the lamp.
formality na kung
Other dignitaries are also requested to join for lighting the lamp.
આવશે પૂરી થઈ જશે. આવ તો હજી છે બી હું અહીં લગાવી બરાબર.
Thank you, sir. Now, before we go to the speeches of our guests, we shall welcome our guest by flowers also. So, first of all, I will request Principal of College of Agriculture, Dr. K. Huns, sir, to welcome our Honorable Vice Chancellor, Dr. V.P. Chodia, sir, by presenting the bouquet. Next, I would like to call upon Dr. Rajveer Yadav, sir, to welcome Dr. K. Huns, sir, by flowers. Dr. Rajveer Yadav, sir, is also requested to welcome our Registrar, Dr. P.M. Chauhan, sir, by presenting the bouquet.
ફૂલ ફેરવી નાખો.
I will request Professor V.R. Wagria to welcome our Director of Extension Education, Dr. H.M. Gajipra, sir. Professor V.R. Wagria is also requested to welcome our Associate Director of Research, Dr. P. Monok, sir. Our Director of Students Welfare, Dr. V.R. Malam, sir, is also welcomed by Professor V.R. Wagria. Now I will request Engineer Geeta Tomar to welcome the Principal and Dean of College of Agriculture, Engineering and Technology, Dr. N.K. Bhotia, sir. Professor D.B. Chavda is requested to welcome the Principal and Dean of Veterinary College, Dr. P.H. Tak, sir. Professor D.B. Chavda is again requested to welcome Head of Farm Engineering Department and Organizing Secretary of this webinar, Dr. Rajveer Yadav, sir. Thank you, sir. Now I will request the Principal of Agriculture College and Chairman of today's function, Dr. K. Huns, sir, to give his introductory remarks on this occasion. Dr. K. Huns, sir.
Good morning to one and all. The dignitaries present in a national webinar on status and strategies for farm mechanization in India, organized by College of Agriculture under NAHEP-IDP. Dr. V.P. Chodia, the chairman of this webinar, and Honorable Vice Chancellor of our university, the chief guest, Dr. C.R. Mehta, Director CIAE Bhopal, both eminent speakers, Director of Extension, Dr. H.M. Gajipra, Dr. P.M. Chauhan, our Registrar, Dr. P.H. Tak, sir, Principal Veterinary College, Dr. N.K. Gotia, sir, Principal College of Agriculture, Engineering and Technology, Dr. V.R. Malam, Director of Student Welfare, Dr. Rajveer Yadav, Organizing Secretary, and Dr. Mohanad, sir. Mechanization also imparts capacity to the farmers to carry out farm operations with ease and freedom from drudgery, making the farming agreeable vocation for educated youth as well. It helps the farmers to achieve timeless and precisely meter and apply costly input for better efficacy and efficiency. All these agricultural operations are possible only when adequate agricultural mechanization infrastructure is created. Even farmers with small holdings utilize selected improved farm equipment through custom hiring. Each farmer can't purchase the machinery setup of his requirement. Therefore, custom hiring facility can be of significance to both unemployed youth and the farmers. Efficient machinery helps in increasing productivity by about 30%. Besides, enabling the farmers to raise a second crop, making the agriculture attractive. Raising more crops with high productivity is path for meeting the future food requirements of population. Development and introduction of high capacity, precision, reliable and energy efficient equipment is the need for judicious use of inputs. I am honored to stand before you as co-PI IDP and for giving introductory remarks of this webinar. First of all, I congratulate organizing secretary and his team for organizing one day online webinar on status and strategies for farm mechanization in India, which is very useful for agriculture sector by utilizing mechanization for reducing cost of cultivation and time to carry out difficult farm operations. Both the topics of today's webinar are very much useful. Dr. C.R. Mehta, Director of CIAE Bhopal, and Dr. Niranjan Prasad, Head Processing Product Development Divisions, Indian Institute of Natural Resins and Gums, Ranchi, Jharkhand. Will talk on mechanization aspect on agriculture and lag production. I would also like to compliment the organizing committee for successful organizations of this webinar. I wish all participants a very bright future and hope that all of you will enjoy the talk selected for today's webinar. Once again, congratulations to all of you and thanks a lot. Thanks.
ચૌહાણ સાહેબ ને ગોટિયા સાહેબ બેન લઈ લો મહેતા સાહેબ ના હોય
Thank you, good sir. Now I will request our registrar and head of Renewable Energy Engineering Department and co-PI of IDP project, Dr. P.M. Chauhan sir, to give the address, give his address on this occasion.
Honorable Vice Chancellor Sahib, respected Dr. V.P. Chovatia Sahib, Dr. K. Khoot Sahib, Principal Agriculture College and ABM, Dr. H.M. Gajipura Sahib, the Director of Extension Education, Dr. P.H. Tag Sahib, Dean, Veterinary College, Dr. N.K. Gontia Sahib, Dean and Principal Agriculture Engineering College, Dr. V.R. Malam Sahib, Director of Students Welfare, Dr. P. Mohanat, Associate Director of Research, Dr. Rajveer Yadav, the Head of Department Farm Engineering, all the faculty members and staff. This is the very good topic selected by the Farm Engineering Department under the IDP, the strategies and for farm mechanization in India and present status. As you know that the farm mechanization is going rapidly day by day because of there are the various problems occurring in the farm. Particularly the present days, the even labor are not that much by hand, they are interested to work, so they need even a very good tools to get the work early as well as the to reduce the drudgery. Similarly, we can see that even nowadays from the Punjab the combined harvesters are reaching to the various corners of the India, even though we are in different states, they are approaching this kind of the combined harvester, uh, the service providers, because uh, the harvesting of harvesting of wheat as well as the paddy is a very tedious harvesting uh, methodology. Earlier were used by using the sickle or by using the reaper, but nowadays the everything that can be harvested, processed, and packed in a single equipment or a machine. So nowadays the combined harvesters are very popular in uh, in either in the uh, wheat or paddy or maybe other different crops, even potato also. The harvesters are very good available. So a lot of developments are going on under the farm mechanization, and I hope that in future the the farmers will be definitely benefited through this kind of the farm mechanization. As you know that present system, the farmers are agitating because of the three latest bills, and because of they are unable to get the proper prices of market, and and the cost of the operations are going high and high. So it is very necessary that the in future that how to develop the such type of the machineries which can be very affordable to the farmers, as well as the systems to be developed so that the farmers get the benefit uh, of this kind of the machinery. Almost all farmers should get the benefit of this machinery, maybe either small farmers or larger farmers, because the farm operations can be done speedily as well as the very precisely, and the losses can be minimized so that the cost effectiveness can be improved. uh, Therefore, there is a need that this kind of the research centers or the prototype centers to be developed in India. As presently, we know that even after such long time, there are the hardly a few research centers are available in India, particularly CI Bhopal, which is working very nicely from uh, uh, since long, and a lot of the machineries have been developed by the CI Bhopal. Uh, However, in different parts of the country, the need of this kind of the machineries or tools are different of specific reason wise, because of the tools are very much specific reason wise, so that the reason wise such kind of tools are developed by the farmers and researchers, so that they can use very judiciously and reduce the cost. Secondly, the present status of the farm mechanization is uh, not that much of in various parts of the country, particularly tribal areas, and still the plows are used, and that plows are still needed the modification and the improvements, and many researchers are working on that. But even though the plows are having a efficiencies are not that much, so a specific reason wise, maybe a tribal area or maybe a very small farm holdings, the different mechanization strategies to be adopted. I hope that in this seminar the director CI Bhopal and my friend Dr. C.R. Mehta will definitely highlight these issues, and we will be benefited through this webinar or lecture, as well as our students will also benefited from his lecture. I again welcome Dr. C.R. Mehta sir, as well as the Dr. Niranjan from the Ranchi, and both speakers are very good speakers selected by the organizers, particularly Dr. Raju Yadav. I congratulate him for selecting this topic, and I hope that all the students will be benefited through this today's webinar. Thank you very much. Thank you.
Thank you, Sean sir, for giving your valuable inputs. Now I will request the principal and dean of of College of Agriculture, Engineering and Technology, Dr. N.K. Kotia sir, to give his remarks on this occasion. Dr. N.K. Kotia.
In today's webinar on status and strategies for farm mechanization in India, the president of today's function and our honorable vice chancellor, Dr. V.P. Chavatia Sahab, the chairman of today's webinar is Dr. K. Khont Sahab, our director extension education, Dr. Gajipura Sahab, the dean faculty veterinary Dr. Tak Sahab, our registrar Dr. P.M. Chauhan, the Director Student Welfare, Dr. Malam Sahab, and Dr. Mohanod, the Associate Director and also the nodal for this NAHEP project, and the organizing secretary of this webinar, Dr. Rajveer Yadav, all the faculty members, the learned speakers, Dr. C.R. Mehta Sahab, Director C.I. Bhopal, and Dr. Niranjan Prasad, who is the head processing division at Ranchi, and all the students who are participating in this webinar. As we know, the farm mechanization is today's the need of the hour. The number of laborers, landless labor, what we call in agriculture, is earlier it was too much, but slowly the labors are reducing in the agriculture sector. Though the total number of labor in India is increasing, but they are diverting in other sectors, and availability of laborers in the agriculture sector is reducing. And not only the number is reducing, but on the other side, they don't want to do hardship. They also, it is our responsibility that we develop the machines, such machines, so they will be helpful to them, and their drudgery should be reduced, their hardship should be reduced. Keeping that's in view, the government of India in 12th five-year plan declared the farm mechanization development and mission mode. And in 12th five-year plan, lot of development has been done for development of the machinery. Then the second thing arises that what about the quality of the equipment? And only we are having only few testing centers across the country, which we are governed by the government of India. Then it was decided that the almost in every state of the India, one testing center should be opened, and maximum of them are working in the agriculture engineering colleges. In for western region or particularly for Gujarat, the testing center is farm machinery testing center is working at this Junagadh Agriculture University, and it is doing very well. And due to these testing centers, the local manufacturers, they have improved their implements because they have to get it tested before the state government or the other state governments give them subsidies. So the subsidies are directed with the certificate of testing of these testing units. So this helped a lot in improving the implements and machinery available in agriculture sector. What happened that due to the such developments, new players also came in the market because the requirement of equipments increased in the agriculture sector. The farmers now using a particular implement wherever specifically required in particular operations. So number of players or the industry people are increased in this industry, and similarly the farmers also, they are purchasing lot of equipment, so there are pressure on the farmers that they should go for hiring of the equipment. So custom hiring is few of the governments, very good custom hiring system has been developed by agriculture engineering graduates. Somehow at Gujarat, we are trying for that. Still, that is not functioning so good because the agriculture engineering division is lacking in the state. But in a neighboring state, very good custom hiring system is there. That is again a need because a farmer cannot purchase all the equipment implements. Every equipment cost to the farmer, and then it remains lying for the whole year. If he utilized for 15 days or 1 month only, and then it will not be utilized. So custom hiring is must. Something is automatically came in custom hiring, suppose combine harvester, the people who are purchasing it maybe of 30-35 lakhs. So they take it whole country. It starts from Junagadh itself. The wheat harvesting starts from Junagadh at the end of the February. They take the combine harvester from Junagadh to whole Gujarat to MP, then UP, and then Haryana, and then Punjab. They reached almost in May or June in Punjab. So that is also a good example of custom hiring of big equipment. Everybody is getting benefited, and few people they are getting the job also in that. So mechanization is a part. It is not that only the mechanization. Some people have a wrong impression that the mechanization increases the cost of cultivation. No, the mechanization is possible through this custom hiring, and the mechanization reduces the seed loss, reduces the fertilizer and pesticide losses, it reduces the water losses, it reduces the wastage of crops, time also reduced. So if the farmer who are taking 3 crops, he may go for 4 crops if he use proper machine, because between 2 crops the crop window is very small, and if he wants to do all the operations within that time, if he gets 1 week or 10 days time, he needs the proper equipment, efficient equipment. So these all things that has put a tremendous pressure on agriculture engineering and particularly farm machinery people, that they should develop the equipments which should be viable for the small farmers also. So small farmers nowadays, in our NAHEP project, we are trying to introduce the artificial intelligence in the machines. So the small machines, they are quite efficient also, and simultaneously they have their own decision making power also. Which means if a small tractor is there, if some implement is attached, it should understand that what should be the depth of tillage, and how much power. If more power is there, it can uplift automatically. Such artificial intelligence is to be added to the implements for efficient utilization of the machinery. Similarly, for spraying, dusting, all these, that what should be the quantity required, somewhere more quantity required, somewhere less quantity. So precision agriculture, what we call, is possible only through the application of such machineries and implements in the agriculture. And farmers also understood this. Slowly the utilization of machinery for particular operations is specific, and farmers are doing that. That's good. And we are also contributing by developing the implements, simultaneously doing very good job of testing. So if a good test is there, naturally a proper tested machine goes to the farmers, it will help to improve their financial conditions. The machine will work for longer and efficiently. With these words, I hope this whatsoever the topic of today's webinar is useful for the our students as well as our the younger faculty also. So in farm mechanization, our the speakers are also very nice peoples are there, and they are masters in their fields. I hope and believe that this webinar will become useful for all the students. With these words, I give thanks to the organizer. They have given me the time to speak. Jai Hind, Jai Bharat, Jai Jai Garvi Gujarat.
Thank you, Bhotia sir, for giving your valuable remarks. Dr. C.R. Mehta sir, Director of Central Institute of Agriculture Engineering, Bhopal, and guest of honor of today's function, has also joined us through virtual mode. He is having a wide experience as far as the farm mechanization is concerned, and he is also one of the speakers in today's webinar. So now I will request Dr. C.R. Mehta sir to address the participants. Dr. C.R. Mehta.
Thank you. Good morning, everyone. First of all, I thank Junagadh Agriculture University, particularly Vice Chancellor of the university, for inviting me for this webinar. Honorable Vice Chancellor of the university, Dr. Chauratia sir, Dr. P.M. Chauhan, Registrar of the university, Dr. Gotia ji, Dean, College of Agriculture Engineering, Junagadh, Dr. K. Kunt, Chairman of this organizing committee of this webinar, my friend Dr. Niranjan Prasad, Organizing Secretary Dr. Rajmeet Yadav, faculties of the College of Agriculture, Engineering and University, students and participants participating in this webinar. I am happy that this webinar has been planned, particularly on status and strategies for farm mechanization in India. And if we talk about it, I think it is need of the hour. It has already been highlighted by previous speaker like Dr. P.M. Chauhan sir, Gotia sir. But I would like to again reiterate that you know that 50% of our agriculture workforce is engaged in agriculture. However, if you see the contribution of agriculture in GDP of our country, it is only around 15 to 16%. This shows that farming in India is less remunerative. If we see the land holding pattern in our country, present average land holding is around 1 hectare. In 2015-16, as per census, it was 1.08 hectare. And if you see the distribution of land holding pattern, 86% of our land holding is below 2 hectare. So we can say that 86% of our land holding is suitable only for individual ownership of small tools and equipment. And our 4% of land holding is about 4 hectares. So which is suitable for individual ownership of energy efficient, high capacity farm equipment. So that highlights the need for going for customizing of farm equipment. If we see the labor availability in agriculture, you may have observed that labor available in agriculture is continuously reducing. Presently, it has gone down to around 45%, and by 2050, it is expected to further go down to 26%. And in that also, you may see that manfolk are migrated to urban area to work in industry. So in rural area, mainly women workers are available, and by 2050 we are expecting that their percentage in agriculture will be around 60%. So that highlights the need for development of gender neutral equipment which can be operated by male as well as female workers. And as I have already mentioned, as well as other speakers have also mentioned, that labor availability in agriculture is reducing, so labor availability in agriculture is reducing, so that highlights the need for mechanization of Indian agriculture, and that is also true for mechanization of Gujarat state also. If we see the food, grain as well as agriculture produce losses in agriculture, in Indian agriculture, it is around 92,000 crores per annum. And if we see the processing level of agro produce in our country, it is less than around 5% of total produce is being processed. Mr. has already highlighted that we have to enhance the income of the farmers, and we have to double the income of the farmers by 2020. So that also highlights the need for going for reduction of cost of cultivation of different crops, as well as we have to enhance the agro processing of the farm produce which is produced in our country. So that will help in even enhancing the farmers' income to double by 2020, or it may even triple the farmers' income by that period also. A few years back, you may have observed in Indian agriculture, mainly we used to use animate sausage based equipments like manually operated, animal operated equipments, and 71% of power in 1971-72 used to come from these animate sources of power. If you see the present power availability in Indian agriculture, it is 90% of power is coming from mechanical sources like from engine as well as from tractors. So that's where we can see that there is mechanization of the Indian agriculture, and this is due to non-availability of labor as well as to reduce the cost of cultivation, because if any farmer go for individual ownership of bigger size of equipment, it may not be economical for that particular farmer. If we see the mechanization level in Indian agriculture, it is not uniform. But then overall mechanization level is around 45%, and in that also, if we see the mechanization in food grain crops, particularly for wheat and rice, is higher as compared to if we talk about cash crops, even like sugarcane and cotton. Cotton is mainly grown in Gujarat state. Their mechanization level is very low, and if we talk about the particularly operations like harvesting, mechanization level is very low, particularly for cotton and sugarcane crops. So that highlights the need for mechanization of horticulture as well as cash crops in our country. And that highlights the role of agriculture engineer in developing the equipments which are suitable for mechanization of these crops. If we see the irrigation area, irrigated area under our country, it is around 50% of the area is under irrigation. And if we observe the trend of water availability for irrigating these area, that is also reducing over the years. So that highlights the need for going for a micro irrigation system, and in that government is also putting lot of thrust through even our prime minister have given the slogan per drop more crop. So in that we have to highlight the need for mechanization or enhancing the irrigation use efficiency using the micro irrigation system in Indian agriculture. In addition to that, we have to enhance the energy use efficiency in agriculture also. So that will also help in reducing the cost of cultivation of different crops, and that we may go for use of even renewable sources based energy gadgets also. Right now, government is putting lot of thrust, particularly on the solar-based irrigation systems, the irrigation pump sets. So in that also government is providing subsidy. So government presently, if you see the farm power availability in Indian agriculture, it is 2.45 kilowatt per hectare. And if you see the power availability, particularly in the states of Punjab and Haryana, it is more than 4 kilowatt per hectare, whereas if you see the power availability in eastern parts of the country, it is around 1 kilowatt per hectare. So that also highlights that mechanization is not uniform throughout the country. I am also going to deliver talk after this inaugural session, so I may also highlight the other issues which are related for enhancing the mechanization in our country. But if we see the present trend of farm machinery research in our country, now we are giving more focus on development of tractor and engine operated equipment, and now we are moving towards development of precision farm equipments. In that also we have developed number of gadgets, but our efforts are towards the development of the gadgets which are affordable by the farmers. Otherwise, farmers may not be interested to operate those equipments, as well as those equipments need to be reliable, and for that also we have to test those equipments, and for that purpose also government of India has established 4 the testing centers throughout the country. In addition to that, 35 more centers have been established in different state agriculture university. One of them is at Junagadh Agriculture University also. So if we have the good quality farm equipments and that reduces the drudgery of the agriculture workers, then agriculture workers may be interested to work in agriculture. Otherwise, they may be interested to go to urban area and work in industry. So that highlights the need for development of the equipment which are energy efficient, which enhance the input use efficiency, and which reduce the cost of cultivation, and which reduces the drudgery of the agriculture workers engaged in agriculture. With these words, I again thank the Junagadh Agriculture University for inviting me for this webinar. Thank you. Jai Hind, Jai Bharat.
Thank you very much, Mehta sir, for being with us and sharing your views with all of us. We have always got the full support from our Honorable Vice Chancellor, Dr. V.P. Chotia sir, for giving a all our academic and research activities. He has always motivated and guided us, all of us in all our endeavors. He is also present with us as the president of this function. So now I will request Dr. V.P. Chotia sir to give his presidential address on this occasion. Dr. V.P. Chotia.
Good morning to all. Today's guest of honor, Dr. Mehta Sahab, Chairman Dr. Kunt Sahab, our Director of Extension Education, Dr. Gajipura Sahab, Director of Student Welfare, Dr. Malam, Dean Veterinary, Dr. Tak Sahab, Dr. Mohanot, Organizing Secretary, Dr. Rajveer Yadav, Dr. Davra, Wagadia, faculties of the Engineering College, and dear participants. We all know that India is an agricultural country with more than 60% population are involved in the agriculture. Indian food grain production has touched to 292 million tons in the current year, which was 51 million tons in 1951-52. So the increase in the grain production, farm mechanization has played an important role and in this achievement. The total power used, as Dr. Mehta Sahab said, the total power used in the agriculture was 0.471 kilowatt per hour in 1981-82, which increased up to 2.2 kilowatt per hectare in 2019 to 2020. However, farm mechanization in India stands at about 40 to 45%, which is still low as compared to developed countries such as USA, that is 95%, 75% in Brazil, and in China it is 57%. A sharp increase in the level of farm mechanization has been observed in the last decade. However, there is a lot of scope of improvement of this sector. Several waste of fruits and horticulture crops is evident, starting from the harvest, post-harvest, transport, storage and up to consumer in India. More than 30 million metric ton of the horticulture produce, and it was spoiled. More than 90,000 crores of rupees are being wasted every year due to the lack of proper handling and proper mechanization. Out of total labor in India, share of agricultural labor was only 60% in 1991, which has been reduced to 52% at present, and it is estimated that it will be again reduced and remain only 25% in 2050. Labor shortage get worse during peak season, which ultimately results in the increase of cost of cultivation, reduction in the production, and increase the risk against the climatic change or climatic factor. The farm mechanization has a potential to attract and retain the migrating rural youth in agriculture. It also provides different stream of employment related to operating and maintenance of the farm machines, thus resulting in the increase the rural employment. India produces and exports an average of 60,000 tractors annually, with market primarily includes African countries and Asian countries where soil and agroclimatic conditions are similar to our country. In our region, Rajkot is the jurisdiction of the Junagadh Agriculture University is coming up as a hub of manufacturing of mini tractors and the other farm equipments. Agriculture engineering graduates of our university are also providing their expertise in this field. In India, more than 60% farm size is less than 1 hectare, which is major constraint in the using of the sophisticated farm implements. However, under the new agriculture policy, there will be a great scope to tackle this constraint as contract farming business establishment provide farmers with specialized farm equipment and various amenities to improve the crop yield through the adoption of latest agriculture technologies. Many companies in the country have participated in such practices before. The continuation and growth of the contract farming with more entities getting involved provides future opportunities for the expansion of the industry. Some of the measures to address the challenges may be promotion of the custom hiring centers, sensitization of the farmers through extension, more affordable, less costlier equipments for small farms. Research should be focused on development of the crop specific and location specific machines. The investment should increase from the private industry for R&D. Farm mechanization reported to save the inputs like seeds and fertilizers by 15 to 20%, labor requirement and operational time by 20 to 30%, increase cropping intensity by 5 to 20%, and crop productivity by 10 to 15%. Therefore, to achieve the target to double the farmers' income by 2022, farm mechanization has major role to play. Precise application of agriculture input like water, fertilizer, insecticide, pesticide not only the reduce the cost but also have positive impact on the environment. Junagadh Agriculture University under IDP project also preparing the future technocrats in this direction to help the farming community by training graduates on use of artificial intelligence, robotics and drone technology in agriculture. 24 students so far have undergone the foreign training and also foreign training in also reputed institutes. I hope the deliberations in this on the status and strategy for the farm mechanization in India will bring out some fruitful suggestions which will be beneficial for the future planning. I congratulate to the organizers for choosing such a relevant topic for the enriching the knowledge of the participants. Thank you. Jai Hind, Jai Bharat.
Thank you very much, Chotia sir, for your kind and motivating words. At the end of the inaugural function, I will request Professor B.R. Vagadia, Assistant Professor of Farm Engineering Department and Co-Organizing Secretary of this webinar, to propose a vote of thanks.
Good morning, everyone. I feel honored and privileged to get opportunity to propose a vote of thanks on this special day. First of all, I would like to take this opportunity for expressing my deep sense of gratitude and heartfelt respect to Dr. V.P. Chodia sir, Honorable Vice Chancellor, for sparing his valuable time from his ever busy schedule to inaugurate and preside over the webinar. Sir, your guidance will be a boost to accelerate the faculty as well as students. I also thank for permitting us for organizing this event at Farm Engineering Department. On behalf of our university, I convey my regards and heart thanks to our chief guest Dr. C.R. Mehta sir, Director CIE Bhopal, for his valuable remarks for this webinar. I wish to express my deep sense of gratitude to Dr. K. Khund sir, today's chairman and co-PI-IDP and principal college of agriculture, for their guidance, support and painstaking efforts in organizing this webinar and making it success. I would also like to our principal sir for encouraging more number of the students to participate in this webinar. I also thank to Dr. Rajveer Yadav sir, Secretary and Professor in Air Engineering Department, for giving me a chance, guiding, coordinating and motivating for the various activities of this webinar. I feel short of words to express my deep sense of gratitude to Dr. P.M. Chauhan sir, Registrar and co-PIIDP, and Dr. N.K. Gotia sir, Principal, College of Agriculture Engineering Technology, for their valuable remarks in this webinar. I also thank to Dr. H.M. Gajipra sir, Director of Extension Education, Dr. V.R. Malam sir, Director of Student Welfare, and Dr. Pramod Mohan sir, ADR and Nodal Officer of ICR, and Dr. P.H. Tank sir, Principal Veterinary College, for sparing his time to be with us and providing guidance to make this webinar a grand success. I wish to express profound gratitude to Dr. C.R. Mehta sir, Director of C.I. Bhopal, and Dr. Niranjan Prasad sir, Head Processing Product Development Division ICR, Indian Institute of Natural Resins and Gums, Ranchi, Jharkhand, for accepting our invitation as a speaker and being with us, who will share their precious knowledge with all of us. I am highly thankful to all the staff of the Farm Engineering Department, staff of Agriculture College, and staff of IT cells, as without their support this webinar could not have been made successful to such an extent. I am thankful to Dr. Paresh Davra for anchoring the program nicely, and I thank Mr. Suresh Parmar for covering the entire event. I am thankful to all those who have directly or indirectly helped us in making this program a grand success. Once again, thanks to all of you.
Thank you, sir. Now it's the time for tea, so we will take 10 minutes break for tea, and all are requested not to become offline during this time. After the tea break, all the sessions will be started. Thank you.
Honorable Vice Chancellor of the University, faculty, students, and my friend Dr. Rajveer Yadav. I again thank organizer for providing me an opportunity to brief about the trend in mechanization of Indian agriculture. I may not repeat number of the things which have been already been covered in the inaugural session, but those are there in my slides also. Okay. As you know, that present food grain production in our country is around 295 million ton, and horticulture production is around 315 million ton. And in inaugural address also I talked about that we have good mechanization, particularly in the area of food grain production, mainly for wheat crop, and then we have a good mechanization in rice crop also. But if we talk about the mechanization in horticulture crops, there is very low mechanization. So that highlights the need for going for mechanization of like other cash crops as well as horticulture crops in Indian agriculture. I already mentioned about the land holding pattern of our country, and it is India is a bottom of pyramid country. Our 86% of land holding is below 2 hectares. So if these farmers go for individual ownership of tractor operated equipments, then their cost of cultivation will increase. So those farmers are encouraged to go for custom hiring or custom service facility of farm equipment. We already discussed a lot about the labor availability trend in Indian agriculture, and it is expected to reduce. Labor availability in agriculture is expected to go down over the years. So that also highlights the need for going for mechanization as well as the development of the equipment which reduces drudgery of the agriculture workers. Then they will be interested to work in agriculture. So we already highlighted why we need farm mechanization. One is we have to, because the land availability for agriculture is nearly constant or it is expected to reduce over the years. Because more area is being brought under the cities as well as agricultural land is being converted for non-agriculture purpose also. So if we go for mechanization, we will be in a position to enhance the cropping intensity because we will be able to complete the operation on time, and that will help in enhancing the production as well as productivity per unit area. If you see the productivity in developed countries, it is very high, and they are very high in mechanization also. Then I already mentioned that we need to reduce the drudgery of agriculture workers, and that is possible by development of equipment which are comfortable for operation by male as well as female workers. In addition to that, we are also observing that there is change in climate over the last few years, and that highlights the need for completing a particular operation in a short period of time, and that is only possible if we go for mechanization. Sometimes we have even heavy rains for a short spell also, and that also creates the waterlogging in the fields. In that case, we can go for raised bed planting of crops also. And if the cost of input is increasing day by day, and if we go for mechanization, we may be able to save the inputs, and that will help in reduction in cost of total inputs as well as cost of production of a particular crop. I have mentioned that there is need to enhance the cropping intensity, and that is possible with the mechanization. And you can see in this slide that over the years, the cropping intensity has increased from 120% to 142% in 16-17, and presently it is around 145%. And if you talk about the power availability, as power availability has increased from 0.36 kilowatt per hectare in 1975-76 to presently 2.45 kilowatt per hectare. There is increase in cropping intensity as well as there is enhancement of food grain productivity also. So we can say that there is direct relationship between power availability as well as food grain productivity and cropping intensity. There are other factors also which are contributing to for enhancement of food grain productivity, but farm power is one of the important component that is helping us in enhancement of food grain productivity. So that also highlights the need for going for mechanization of Indian agriculture. If we see the trend in farm power availability over the years, you can see that 71% of farm power available in 1971-72 was from animate sources, means human power as well as from animal power. And presently it has gone down to less than 10%. And in that, in mechanical sources of power, their main contribution is by the tractors. But if we see the implements, tractor with machinery being used in India, only a few implements are being used, and that also highlights that we have to move from tractorization to mechanization, and that is happening particularly in the developed country. But in our country, we are giving more emphasis on tractorization because tractor can be used for other purposes also, but we have to give more focus on mechanization, and that will reduce the cost of cultivation as well as that will also help in timeliness of carrying out different farm operations. If we see the sale trend of tractors over the years, and here you can clearly see that there is increase in sale of higher horsepower tractor, particularly in the range of 31 to 37 kilowatt tractors. And presently, it is having market share of around 47%. And in you can also see at the bottom that there is increase in sale of low horsepower tractors also, and those tractors are mainly being used particularly for carrying out different operations in horticulture crops like grapes, pomegranates, etc. Even small horsepower tractors are also being used for preparation of land for paddy cultivation also. Vice Chancellor Saab has already mentioned in the inaugural address that if we see the mechanization trend in developed countries, we can say that we can observe that mechanization in developed countries like US and Europe is more than 95%. However, its contribution to the GDP of that country is only 1 to 2%. In addition to that, also manpower engaged in agriculture is also very low in those countries. So those countries are highly mechanized. They are going for use of high capacity farm machinery with bigger size of tractors. And their land holding size is also very high. That's why they are having higher food grain productivity. Whereas in developed countries like India, you can observe that presently mechanization level is around 45%. However, its contribution to GDP of our country is around 16% also. But if we see our neighboring country, they have a small land holding, but their mechanization level has gone to 65% presently. But their contribution of agriculture in GDP of that country is around 8% only. So that highlights that we have to enhance the mechanization in Indian agriculture, and that also for particular specific crops in which we have low mechanization. In this slide, you can see overall mechanization level for major crops is around 45%. And in that also land preparation is highly mechanized. Particularly for rice and wheat, we can say that it is nearly mechanized. But if we see the transplanting of rice, only 30%.
So that highlights that we have to, and this is most drudgery prone operation also. But due to non-availability of the labor, particularly in the southern parts of the country, as well as during this season, transplanting season, there was shortage of labor availability in Punjab also. So, so these states have gone for custom hiring of working time type as well as riding type rice transplanter. But still, there is lot of scope for mechanization of rice cultivation, particularly rice transplanting operations in our country. And for like cash crops, I mentioned in inaugural address also for harvesting. If we talk about cotton, there is no mechanization because in India we have multiple picking of cotton. We some companies have all introduced cotton picker also, but those are not successful due to multiple picking as well as high stress content also. In sugar canes, there is enhancement in sugarcane harvesting during last few years due to government of India plans on submission on agriculture mechanization, and they are providing subsidy up to 40%. But there is a scope for mechanization of number of operations in different crops. So what should be our approach to mechanization of Indian agriculture? We have to enhance the use efficiency because the cost of the inputs are increasing over the years, as well as we have to enhance the cropping intensity, and that is possible with the enhancement of farm power supply in our country. Presently, it is around 2.45 kilometers. Some states it is above 4 hectares like Punjab and Haryana, but in eastern part of country as well as in hill, farm power availability is very low. So that highlights the need for enhancement of farm power supply. And if we are able to enhance the farm power supply with the support of machinery, we will be able to reduce the cost of production as well as we will be able to reduce the drudgery of the agriculture workers engaged in agriculture. And we have to maintain a socially desirable mix of human labor, drought animal power, and mechanical power to be used in Indian agriculture because the condition of different states as well as different topography is different. Particularly in hill area, we cannot go for use of tractors. Then we have to go for self-propelled, manually guided farm equipments to be used on in hilly areas. So what is trend in farm mechanization in our country? We have already mentioned that we need to reduce the cost of inputs as well as we reduce the cost of ownership of farm machinery, and that is possible only through the custom hiring or contract farming, because government is also putting thrust on contract farming during last few years. And for that also we need this service as well as support partners. Uh, all of you are well aware about Ola and Uber, and in most of the cities we are using their services for hiring of taxi. Similar services also have been launched, particularly for hiring of farm machinery in our country. But uh, this their availability of farm machinery through those services are limited right now. But in future, we are expecting that such services will be popular in our country also. If you see in developed country like USA, they are mainly using app-based system for hiring of farm machinery in their countries. Now I come to the mechanization trend, particularly for different operations for crop production. And if for land preparation, we can see that we have animal operated equipment like on top left hand side, blade harrow is shown. Then we have power tillers also. Nowadays, even lightweight tillers have also been introduced in our country. And then we have the tractor operated equipments like rotavator is nowadays getting very popular. And in Gujarat is one of the leading state in the manufacture as well as export of rotavator in our country. And rotavator can be used for dry tilling as well as for puddling of field, for preparation of field for paddy cultivation. Then we have both tractor operated, power tiller operated, as well as self-propelled post-hole diggers also. And nowadays, farmers have started using the laser-guided levelers, particularly in dry land area where mainly rice crop is being grown, and that is helping is saving of water by around 20 to 25%, as well as that also enhance the productivity of that crop. And nowadays we have developed the laser guided system for wetland puddling also. And recently our Coimbatore center of TNU have developed this equipment, and they have licensed to one of the leading farm machinery manufacturers located at Chennai. I talked about the mechanization of hill agriculture, and there will be relevance of even uh, quality farm equipment to be operated by animal as well as by lightweight tillers in those regions to reduce the drudgery of the agriculture workers engaged in those regions. For sowing and planting also we have different kinds of equipment, even manually operated. We have Navin dibbler, rotary dibblers. Then we have the animal operated incline pair planter, in seed cum fertilizer drill. Then we have tractor operated crop specific equipment as well as general multi crop planters also, like raised bed planters that is suitable for regions where we have heavy rainfall, particularly for short spell also. And for dryland region also, this is suitable for conservation of moisture. Then we have this for small seed planters. Then the crop specific planter, like this is the seed spice planter, which has been developed by MPOT with the help of one manufacturer in Gujarat. And nowadays, even farmers have started using pneumatic planters to save the cost of the inputs, particularly seeds. And now, as we have introduced mechanization of Indian agriculture, we need to see the soil health also, and for that purpose, it has already been highlighted at number of farms. We have to go for conservation agriculture. In that, we have to go for minimum tillage of the field, as well as we have to leave the crop residue on the soil surface. And for that purpose, also number of even power tiller operated zero till drill have been developed. Nowadays, zero till drill, strip till drill, rotor till drills are being popular, are getting popular, particularly in the Indo-Gangetic plain for cultivation of rice and wheat crops, because the after harvesting of rice, for sowing of wheat, very limited period is available, and for that purpose, farmers are going for burning of the crop residue to clear the fields. So in those fields, we can go for direct sowing of the wheat seeds without preparation of field using such machinery. For hilly region, we have to promote the lightweight tiller operated different matching implements like seed drill as well as seed cum fertilizer drill, even reaper also. For planting also, we have developed number of crop specific planters as well as multi-purpose planters also. So on the top left hand side, you can see that semi-automatic vegetable transplanters have been developed, particularly for transplanting of tomato, capsicum, and other brinjal and other crops, seedlings of those crops. Then for sugarcane also, we have developed the multi-purpose sugarcane equipment, and nowadays these are getting popular. And for potato planters, semi-automatic as well as automatic potato planters are nowadays getting popular in our country, and also in particularly in Gujarat states. Even some of the farmers are importing potato planters from world leading companies like Grime also in Gujarat state. And even a few farmers have also purchased the potato combine, particularly in the Dholpur Kampa region of the Gujarat. So the farmers are moving towards higher quality farm machinery, for mechanization of different crops in different regions of the country. And Gujarat is one of the advanced states which is leading the mechanization of Indian agriculture. And then we have the also turmeric rhizome planters suitable mainly for turmeric growing area. So that is crop specific planter. Then for sugarcane bud chip planting also, bud chip seeding planting also, we have developed the sugarcane bud chip planter. It has been commercialized on a large scale. And recently, Tamil Nadu government is providing this equipment under submission on agriculture mechanization in that state. Then presently we are developing the sensor-based planters also for sugarcane. In that the herbicide application is using sensors, and as well as sensors identify the nodes and do the planting. For rice transplanting, I have mentioned that there is around 30% right now mechanization level. It is increasing over the last few years. But still some part of rice plant transplanting is still being done manually, and it involves lot of drudgery of agriculture workers engaged in agriculture. For that we have different options. Even we can go for direct seeding of the rice, even we can go for like a sowing of pre-germinated seeds using drum seeders, and that is also getting popular, particularly in some states like Tamil Nadu, Bihar, etc. Then we have manually operated transplanter of different like 2 rows, 4 rows, 6 rows. Then nowadays even 2 row root wash seedling type transplanter have also been introduced. Then we have the self-propelled 4 row rice transplanter, then riding type 6 row and 8 row rice transplanters. And these transplanters are getting popular, particularly on the custom hiring basis in southern parts of the country. In that, if farmers generally prefer that if the nursery is also grown by the transplanter and operators, then it may be it will be having more acceptance. For interculture operation, also we have manually operated equipment, then self-propelled equipment. Then recently, a few years back, we developed the power weeder for rice crop 2 row. It is also popularized on a large scale. Then we have the fertilizer placement come earthing up equipment, particularly for wider space crops like sugarcane, etc. Then we have the tractor operated rotary weeder. And nowadays our focus is to develop the multi-purpose equipment, and at our institute we have developed the high clearance vehicle which can be used for carrying out different operations like spraying, weeding, and harvesting. And in that, we can adjust row to row as well as we can adjust the height of the platform. Also, if we import such equipment, those cost around 25 lakhs. And we have developed it at our institute. It cost only around 8 to 10 lakh rupees only. And right now, we are in the process of licensing of this equipment to a few manufacturers. For plant protection equipment, everyone are well aware about the use of NAHEP manually operated knapsack spares. In addition to that, animal drawn spares are also being used. Then self-propelled spares are also developed, but those are not very popular. Then we have the tractor-operated horizontal boom spare, then aeroblast spare, air-assisted spares, and present trend is towards the development of sensor-based spares, so which identify the plant canopy and do spraying only on the plant. So it helps in saving of the chemicals by around 50%. Particularly the horticulture farmers like grapes growing farmers as well as pomegranate farmers, they are going for good quality spares and dusters, and though they are even importing such equipments from other countries also. So actually it shows that our farmers are interested for good quality farm equipments for use on their crop, uh, for use with their crops in their fields. And we have to develop, or we have to indigenize development of such equipment in our country also. For harvesting, still in some part of country, sickle is being used, and for that purpose we have developed a serrated sickle a few years back, and it is giving around 20% more output as compared to the sickles being used by women workers in Indian agriculture. In addition to that, we have vertical conveyor reaper nowadays, self-propelled reaper binder as well as tractor-operated reaper binder have also been introduced in our country. There are a few manufacturers of such equipment in Rajkot, in Gujarat also, and then we have the tractor-operated vertical conveyor reaper also in our country. We have also developed the multi-purpose platform for fruits, so that is suitable for spraying, pruning, as well as picking of fruits, and it can go up to 6-meter height. And we have licensed this equipment to TAFE Limited, Chennai. And nowadays, even Tirth Agro, Rajkot-based company, has also started manufacturing this equipment, and it costs around 7.5 lakh. We have also developed different kinds of coconut harvesting gadgets, and you may have also seen the number of videos of different kinds of coconut harvesting. Even one engine operated coconut harvesting device also. Presently our efforts are to develop the sensor based coconut harvesting robot also. We have also initiated a working in that area. And for threshers also we have multi crop thresher as well as crop specific threshers. So for paddy, we have the axial flow thresher, multi-crop threshers. You can see on the top right-hand side, such threshers are being used particularly in the states of Punjab and Haryana on custom hiring basis, not only for rice and wheat crops, but for like pulses also. Then we have crop-specific threshers also, and even in Gujarat, there are a number of good manufacturers of groundnut threshers also in Gujarat. In inaugural address also, it was mentioned that in our country, harvesting of rice and wheat, these two crops are mainly done using the combine harvesters. And for that also, we have self-propelled combine as well as tractor on top combines. Particularly, tractor on top combine is popular, particularly in the southern part of our country, due to their low cost. And for straw management also, we have developed a number of machineries are available, even racks, balers, as well as straw combines. And what is the trend in Indian agriculture, particularly related to mechanization? Because everyone wants to be smart, like we want to be smart. Every day we are changing our mobile phone at frequent interval to be more smart in carrying out our day-to-day activities. So farmers are also are interested to be smart. Nowadays they are checking YouTube also, and they are even raising their query that where such kind of machinery will be available. So if we want to make the farmers smart, then we have to go for electronic technology which can make equipment smart, and that equipment should be operated by male as well as female workers, because in future we are expecting that there will be more women workforce engaged in agriculture, and they may not be used as a source of power, but they may be used as a controller of the power also. Like nowadays you may have seen that cars are being even run by females also, and now in future you may see the similar trend, particularly operation of tractor as well as bigger size machinery by female workers also. So in the future, we are expecting what will be the system. Presently, implements guide the system, but in future, we are expecting that even tractor guides the implements. In future, we are expecting that implement may guide the tractors based on the requirement of that implement to carry out that particular operation in the fish in the field, and that will highlights the need for going for true system in which the tractor and implement will function as one. And we have already started working on supervised autonomy, means we have already started working on development of unmanned or remote control, even power tiller tractors, and we have also initiated working on remote control like rice transplanter also. So in future, we are expecting that we may even go for full autonomy, means it just press a button from remote and it will carry out the farm operation in the field. But those technology may not be immediately used in our country. It will take time. And for that purpose, we need the communication system. In that, a smart telematics will be required. Then we require data management also. For that also, we need the service providers. In that, even right now, we are talking about 5G, mobile services, internet service providing also. And for that also we need the smart connection with farm management systems. Management system is even for like machinery also we need such technology. So those can be operated remotely, or those can be even their operation can be monitored remotely. Even in like in some tech Indian tractors also such technologies have just been introduced on limited scales. But for example, John Deere has introduced JD Link tractors. So that can be that can remotely monitor the operations which is being done in the field. So now we are moving from mechanization 1 to mechanization 2.0. Someone may talk about mechanization 4.0 because industry is moving towards 4.0, but I will call it mechanization 2.0, from like animate and to mechanical, and then now we are moving toward the precision farm equipment. So in that we are expecting farming as a service fast. In that app based like Tringo, even from Mahindra has been launched, even J Farm from Tefe have been launched, a number of other applications are also there. In that farmers and those who are in a position to provide service as well as those who need service are joined together, and that will help in even reducing the cost of ownership of the farm machinery, as well as that help in farmers in getting the machinery on time. But limited farmers or as well as service provider have enrolled with such service. But in future we are expecting that there will be popularization of such service, and more service providers as well as farmers will be enrolled with such service providers. Another, then there will be a role of big data. Big data means, for example, if we operate any machinery based on the sensor, or if we operate any irrigation system based on the sensor, that requires data, particularly like how much input to be applied in a field at a particular location, and that data even have to be analyzed. Even we have to analyze the rainfall data also to predict at what time we are expecting rainfall to happen, so we may plan our sowing operation as well as harvesting operations like that. So there will be role of big data. And nowadays we are talking about the use of IoT and AI in agriculture. So those technology will be used particularly for the operations which are difficult to carry out manually, or for the remote monitoring of the operations. Even for like a IoT based irrigation system can also be, we have started working in that area, but those can be installed by the farmers. Cost is also not very high, and farmers can remotely monitor their irrigation system, as well as it can be put on and off based on the moisture content in the field. And particularly for some operations which are difficult to carry out using manual as well as mechanical sources of power, there will be application of AI, particularly for weeding, spraying, and harvesting operations that will enhance the accuracy of the operations, as well as that will help in reducing the drudgery. For example, coconut plucking, we can go for use of AI-based robotic system. So that will identify the right coconut to be plucked, and it can be remotely plucked. I will not go into much detail of the kind of equipment which have been developed, particularly in the area of precision agriculture, but we have initiated working in the area of precision agriculture and developed number of equipment during last 8 to 10 years. And that one is the ground speed sensor based seed cum fertilizer drill. So whenever there is skidding as well as slipping in the field, at that time even that metering of the seed is stopped. So it monitors the forward speed of this tractor, and on that basis it varies the seed in the field. Recently, TNU Coimbatore have developed the pelletized rice seeders also, because seeding or as well as transplanting of the seedlings in the rice field is drudgery prone, and for that this equipment have been developed which can be remotely controlled from out of the field, and it helps in the seeding of pelletized seeds of rice. We already discussed about the automatic sprinkler irrigation system. At our institute, we have developed the telemetry-based sprinkler irrigation system, which is put on and off based on the moisture content of the soil in the field. And right now, we are working on the IoT-based irrigation systems. This is the light sensor-based spade meter, which we have developed at our institute. At the top left-hand side, you can see the one spade meter of Minolta, which is useful for chlorophyll content of the for measurement of chlorophyll content of the leaves. On that basis, fertilizer application dose can be recommended, and that cost around 1.5 lakh. And we have developed the light sensor based spade meter, and it is also having similar accuracy and cost only around 5,000 rupees. We have also started working in the area of development of variable rate fertilizer applicators, but in that we have first prepared the nutrient variability map of the field. We have prepared it manually, and then we fed that map to the controller, and then the controller gives the instructions to that metering mechanism of that fertilizer distribution system, and on that basis, based on the nutrient availability at a particular locations, the fertilizer application rate is varied in the field. But we don't see that such technology may be immediately applied in Indian agriculture. Right now, we have started working on measurement of real-time nutrient availability in the field also. This is the uniform rate spraying system which have been developed at our institute. What happens with presently available sprayers, that whenever there is change in forward speed of the tractor, that spraying rate is uniform, but this sprayer monitors the forward speed of the tractor, and on that basis it varies the chemical spraying rate in the field, as well as whenever the headland tractor takes a turn, it stops the spraying of the pesticides in the field. So that also helps in even saving of chemicals, as well as it helps in maintaining uniform rate of spraying throughout the field, irrespective of the forward speed of the tractor. We already discussed about the sensor-based sprayer. So in that also, IIT Kharagpur as well as MP UAT Udaipur have worked, and presently we are in the process of licensing of such equipment to a few farm machinery manufacturers, particularly in the states of Maharashtra. Nowadays, everyone is talking about the application of drones in agriculture. We have also initiated working in that area at some of the state agriculture university, as well as at ICR Institute also. But we are in the initial stage. So we have identified crop spraying as the one area. Another is for crop like health scouting also, to identification of the disease, using the drones, and do the spraying only at that particular location. And there are a number of other areas also where we find that there is potential for use of drones in Indian agriculture, and we are also recommending that drones may be brought under the submission on agriculture mechanization. So farmers, those who are interested to use drones, they may get the subsidy on that. In developed countries, you may have observed that seed drills are with yield monitors also. So at our institute as well as in PI Ludhiana also, some studies have been carried out to monitor the yield variability within the field, so we can take the decisions of the application of nutrient as well as the other measures for enhancement of crop productivity in different crops. So we already talked about this subsidy and submission on agriculture mechanization. So in that also, Government of India is putting lot of thrust for increasing reach of farm mechanization to small and marginal farmers. And for that purpose, is government is providing subsidy up to 40% for individual ownership of farm equipment as well as for custom hiring of farm machinery. In addition to that, under that submission on agriculture mechanization, testing of farm machinery is also being done at 35 centers located in different parts of the country to have quality farm equipments as well as the high cost, high capacity equipment like sugarcane harvesters, etc., also being promoted under submission on agriculture mechanization. You can find the details of this on the website of Department of Agriculture, Cooperation and Farmers Welfare. So we have large network of testing of farm equipment. Four bigger institutes are under Government of India, as well as we have 35 institutes in SAUs, ICR Institute, even at IIT, as well as in the state government. So we talked a lot about different kinds of equipment from manually operated to sensor based. And we can develop the cheaper quality sensor based equipment because India is world leader in IT as well as tractor and farm machinery manufacturing. In addition to that, we have large network of agriculture research system, and we have to promote the entrepreneurship for custom hiring of farm equipment, even for precision equipment also. And we have initiated working in the area of use of sensors, AI, IoT in agriculture. But for that also we need HRD of the scientists as well as the researchers engaged in that area. And in that we need the support of government as well as private sectors, particularly for precision farm equipment. Those need to be reliable. Then the farmers will adopt reliable as well as affordable. Then the farmers will adopt such technology. So now I come to the end of my talk, and I again highlight that there is need for going for high capacity machines, particularly to be used on custom hiring basis, because those machinery will be having used for a limited hours or limited days in a field. So if we go for custom hiring, then the cost of operations, cost of ownership of those machinery will also reduce, as well as cost of cultivation of that crop will also reduce. And there is need for going for whole crop mechanization. For example, some operations are highly mechanized, but some operations for a particular crops are not at all mechanized. If you talk about even cotton. So that highlights the need for mechanization of full crop mechanization, and we have to give more focus on mechanization of horticulture crops because horticulture production has even surpassed the food grain production also. Then we have to give more focus on export of quality farm equipment to other country. In addition to that, we have to give more focus on the development of those equipments which are being imported in our country from our neighboring countries also under Atmanirbhar Bharat also, and government is putting lot of thrust on that. And we have to develop the appropriate technology for mechanization of the hills, particularly horticulture crops, because if you see the mechanization in hills, there is nearly very low or nil mechanization. And that area that need more attention in future will be precision agriculture for enhanced input use efficiency due to the increase of the cost of the inputs day by day. Then conservation agriculture for carbon sequestration for maintaining the soil health. Then we have to reduce the drudgery of the workers engaged in agriculture. So we have to give more focus on occupational health and safety of the workers as well as development of the equipments, keeping those points of view. Then the farmers or their son will be interested to continue to work in agriculture. In addition to that, we have to give focus on farm machinery management, means we have to match the tractor with proper size of implements. Otherwise, what is happening that we have started moving towards higher horsepower tractors, but implement size had not increased. And then we have to go for application of sensors, microprocessors, and computers in agriculture for enhanced input use efficiency. And in the future, we are expecting that agriculture in India will be dominated by cost-effective technologies like smart tractors, UAV like drones, and wireless technology like IoT-based irrigation and fertigation system. This is all in brief about my talk. You may visit our institute for more information about the recent work which is being done at our institute. Thank you. Now we can take questions. Thank you. Gujarat is an advanced stage, particularly if we talk about the farm machinery manufacturing. So maybe student may be well aware about the technology which are being developed. And I try to have my talk not more technical, just for information like that. What kind of efforts are being made? What is trained in mechanization, particularly in Indian agriculture?
It was very good for students.
One question is there in chat box. What was that question? Just how to? I'm not good in particularly this. Okay, I got it. Is there any improved harvester for garlic crop?
Garlic crop.
Yes, garlic harvester has been developed by our NPUT Udaipur Center and with the help of one manufacturer at Rajkot.
Rajkot.
Yeah. Particularly the farm machinery manufacturer in Gujarat are very good. One, we are having good farm mechanization manufacturers, particularly in the states of Punjab. After that, Gujarat is one of the leading states. There are number of places in Gujarat like Rajkot, Mehsana, then near Palampur also.
Unja.
Number of good manufacturers even for seed specific crops are also there.
Yeah.
But actually, what I suggest, even we have to observe those manufacturers. We have to have close linkage with those manufacturers. So we will be well aware about the development as well as we may be associated in the development process also with manufacture.
Any question? जी, कोई question?
Any faculty can also raise their question or queries also. If I know, I shall try to answer. I haven't covered processing in my presentation because there is one talk on processing, particularly by Dr. Niranja Prasad, and I think he will be giving more focus on lag processing.
Yeah.
Yeah, Adab Saab, if there are no questions.
Sir, one question. What is the utility of ergonomics in agriculture?
Ergonomics, utility of ergonomics in agriculture will be very high. I mentioned that lot of drudgery involved in agriculture, and farmers are not interested to work in agriculture if they have any other options also. So ergonomics actually we have to consider while designing the machinery.
Yeah.
What we have observed during last few years that we have started working ergonomics related aspect after machinery have been designed. So while designing the machinery, we have to give all focus on ergonomics. Ergonomics means how the machinery is being operated by a particular person and what are his or her capability to operate that equipment. On that basis, that equipment has to be designed. So that will be comfortable for that person to operate that equipment, as well as it will give more output because the person will be able to operate that particular equipment for a longer duration.
Any question? कोई क्वेश्चन है?
हिंदी में भी पूछ सकते हैं, गुजराती में भी पूछ सकते हैं, मैं थोड़ा समझ सकता हूँ.
हाँ, नहीं
थोड़ा समझ सकता हूँ, ज्यादा नहीं.
नहीं, समझ तो सकते हैं. गुजराती और हिंदी में बहुत ज्यादा डिफरेंस नहीं,
ज्यादा टिपिकल गुजराती होगी तो थोड़ी हो सकता है वो समझ में नहीं आए. थोड़ा मेरा भी टच है गुजराती.
अच्छा सर, दूसरा क्वेश्चन है कि ये जो बीटी कॉटन है ना, उसमें अगर हमें हार्वेस्टिंग करना है तो देयर इज वन लिमिटेशन particularly for the stripper or harvesting machinery. It requires single stage ripening variety. But what is about a BT cotton for harvesting?
नहीं, आप सही कह रहे हैं कि सिंगल स्टेज क्रॉप वैरायटी चाहिएगी. फिर उसके बाद पर्टिकुलर वैरायटी भी वो होनी चाहिए जिसकी हाइट मतलब 4 फीट से ज्यादा ना हो. फिर उसके बाद ये इसमें क्या होता है कि मशीन से हार्वेस्टिंग खासतौर से स्ट्रिपर की जगह स्पिंडल वाले ट्राई किए हैं, फिर भी अच्छे काम करते हैं, लेकिन उसमें भी ट्रेस कंटेंट हाई है. तो उसके लिए फिर आपको प्री क्लीनर लगाना पड़ेगा, तो काफी कॉस्ट बढ़ जाती है. तो उस डायरेक्शन में और कुछ एफर्ट कर रहे हैं, लेकिन उसके लिए क्या है कि ब्रीडर्स को भी साथ में काम करने की जरूरत है. केवल इंजीनियर्स का रोल नहीं है कि आपको वैरायटी चाहिए उस टाइप की, प्लस उसमें डी ग्रोथ भी यूज करना पड़ता है और भी कई इश्यूज है. इसीलिए एक एफर्ट्स भी हुए हैं. कहीं जॉन डियर ने यहाँ तक कि कॉटन पीकर बनाया भी था, टेस्ट भी कई जगह किया, लेकिन वो इसलिए पॉपुलर नहीं हुआ है कि अभी फार्मर्स उस वैरायटी पर स्विच नहीं हुए. जब तक क्या किसान को लेबर मिल रही है तब तक तो चलेगा. आगे जब नहीं लेबर मिलेगी तब फिर स्विच होंगे मशीनरी की तरफ, तब फिर वैरायटी भी यूज करेंगे और मशीन भी रहेगी. अभी जैसे राइस ट्रांसप्लांटिंग में हुआ है पंजाब में इस सीजन में, आपने देखा होगा कि इस बार लेबर उनको दूसरी स्टेट से मिली नहीं क्योंकि लेबर सब अपने घर चली गई और सीजन में आई नहीं. तो इस बार उनको काफ़ी करीब 25 to 30% एरिया जो मैनुअल ट्रांसप्लांटिंग होता था वो अब राइस ट्रांसप्लांटिंग उन्होंने सेल्फ प्रोपेल राइस ट्रांसप्लांटर और राइडिंग टाइप राइस ट्रांसप्लांटर से किया। तो अब धीमे धीमे लेबर अवेलेबिलिटी एग्रीकल्चर में कम हो रही है और वो होगी भी सही, क्योंकि जब आपको उस रिटर्न अगर इंडस्ट्री में काम करने में ज़्यादा मिलेगा तो एग्रीकल्चर में फिर लेबर कम मिलेगी काम करने के लिए।
अगर किसी को पूछना है कुछ
Any more question? Otherwise, we will.
any more question from student side?
स्टूडेंट कह रहे होंगे कि मशीनरी की बात कर रहे हैं लोग, वो सब एग्रीकल्चर वाले हैं, 1-2 कोर्स रहते हैं मशीनरी के।
नहीं, कुछ को तो इंटरेस्ट रहता है।
लेकिन गुजरात वालों को मशीनरी के बारे में समझ ज्यादा होनी चाहिए, जो मेरी सोच है, चाहे वो स्टूडेंट एग्रीकल्चर का हो, क्योंकि गुजरात में मैंने देखा है कि अवेयरनेस बहुत है, मैन्युफैक्चर बहुत अच्छे हैं, यहाँ तक कि अच्छी अच्छी पोटैटो कंबाइन तक इंपोर्ट करते हैं, ग्रीमे वगैरह की। तो गुजरात वाले वैसे ही बिजनेस में अच्छे होते हैं, तो अच्छी मशीनरी भी अगर उनको कहीं नजर आती है बाहर से तो इंपोर्ट करने में भी नहीं झिझकते, रिवर्स इंजीनियरिंग करने में भी नहीं झिझकते।
Okay, if there is no question, then thank you very much, Mehta Saab, for sparing
Welcome.
sparing your
Thanks for inviting me.
valuable time, as you have a very busy schedule. As you talked today afternoon, also you have a lecture. So we are
Yes.
thankful to you for
Thank
sharing
you.
your knowledge on mechanization implements for different crops. Thank you very much, Daksha.
Thank you, Rajveer ji, for inviting me. And if there is any more question from anyone, they can send by email also. We will try to answer those questions.
Okay. Thank you.
Thank you.
Once again. Thank you, sir.
Thank you. So kindly permit me, I am leaving now.
Thank you, Daksha.
Namaskar.
निरंजन प्रसाद उसमें जुड़े थे सुबह?
निरंजन प्रसाद होता
सवार में नहीं आया? अच्छा। चलो ऐसा होगा दोपहर में जोड़ देना, बोलना पड़ेगा फोन से।
ત્રણ વાગ્યાનું છે તો આપણે આવી જશે
ઓપન એનાઉન્સમેન્ટ કરજો સ્ટુડન્ટને આપણે કેટલા વાગે ચાલુ કરવા છે?
3 વાગે
3 વાગે.
3 વાગે છે ને તો 2:45 બધે જોઈન થઈ
Link
જાય.
In the afternoon session, we will start from 2:45. So all the participants requested to join again at 2:45. And Dr. Niranjan Prasad from Ranchi, ICR, will talk on the lag production and processing. So we will meet at 2:45. All of you. Thank you. Hello. Good afternoon to all of you. We will start the afternoon session. We will invite Dr. Niranjan Prasad, Head Processing Product Development Division, Ranchi, Jharkhand. for the afternoon session. He will speak on lag production, processing and overview. हेलो निरंजन जी सुन रहे हैं? आवाज आ रही है?
माइक उनका बंद है। माइक बंद यहाँ से बोल दीजिए।
हाँ, आपका माइक बंद है।
એમનું બંધ થઈ છે।
इनका बंद है?
Sir, you have to unmute yourself from the computer itself, sir. You have to click on the unmute button on the screen.
Now it is.
Yes.
Now my
yeah.
voice is coming.
Yes,
Yeah.
yes, sir.
Now it is okay.
Okay. So any other formalities is to be done, or I should start? So may I start my presentation? So my PowerPoint is visible now. It is visible now, but it is showing on my screen. It is okay now. Honorable Vice Chancellor, Junagadh Agricultural University, Honorable Dean, College of Agriculture, Junagadh Agricultural University, Dr. Rajveer Yadav, Organizing Secretary and Professor, Department of Farm Engineering and faculty member and staff member of Junagadh Agricultural University, students of College of Agriculture and other faculty of Junagadh Agricultural University. Welcome to my presentation on mechanization of lag production and processing and overview. In the morning session, I hope Dr. C.R. Mehta, Director CIA Bhopal, has a lecture on trend in mechanization of Indian agriculture. So my presentation will be a bit different from his presentation. And here, first of all, I would like to say that I have divided my lecture in 3 parts. That is introduction to natural resins and gums, and the topic on which I am speaking is also a natural resin. So first of all, I will introduce about natural reagents and gums. Then we will have some discussion on mechanization of lac production. And lastly, we will discuss on processing of lac. So I will now start my first topic, that is Indian natural reagents and gums, a potential source of livelihood in forests, subforests, arid regions and mountains. Natural reagents and gums. India is a rich center of plant biodiversity, and over 45,000 plant species, including 120 gum and resin yielding plants are there. In the world, India, Indonesia, China are largest producer of natural resins and gums, and it is a multi-billion-dollar global industry. And India is leader in production of guar gum, craya gum, and lac. So let us know what is resin. It is a solid or semi-solid material, usually a
बाबा आंबेडकर
Hello. Now presentation is visible.
Yes, sir.
I can start now. Okay. Then I think this slide I have already shown. My talk is on mechanization of lab production and process and overview. I have three parts: introduction of natural reagents and terms, mechanization of lab production, and lab processing. Yes. Voice is not. Now it is coming. Hello. Hello. Sound is coming. Sound is not coming.
Coming.
Hello. Okay, then I am starting now. So my first presentation is on natural reagents and gums, potential source of livelihood in forest and subforest, arid regions and mountains. So India a rich source of biodiversity, over 45,000 plant species, including about 120 gum and resin yielding plants are there in India, which produces gums and resins. And in the world, Indonesia, India, and China are largest producer of natural resins and gums. And it is a multi-billion dollar global industry. India is largest producer of guar gum, karaya gum, and lac. And now coming to what is resin? It is a solid or semi-solid material, usually a compound mixture of organic compounds called terpenes, which are insoluble in water but soluble in certain organic solvent. For example, lac is a resin and it is produced by insect. Otherwise, other resins like rosin, copal, and damer are produced by tree directly due to some injury on the tree or due to some adverse condition like very dry spell, high temperature, and low humidity. And then coming to gum, it is a polymeric material that can be dissolved or dispersed in water to give thickening or gelling effect. And source of gum would be tree or plant seed, microbes or seaweeds. And examples, some of the examples are guar gum, karaya gum, gum arabic, xanthan gum, etc. Then there is a third category known as gum resin. Actually, it is a natural mixture of gums and resins in variable proportion. Therefore, it contains property of both the groups, gums as well as resins. And they contains also sometimes traces of essential oil and have penetrating and characteristics odor or taste. Examples of gum resin are Asafoetida, Meyer, Google, Olivanum, and again source is a plant. It is a secretion of the plant. Now coming to application of natural resins, gums and gum resins. Resins are used in paint industry, varnish, lacquer, cosmetic, adhesive, medicines and food industries. Gums are used as a thickening agent, gelling agent, stabilizer, emulsifier in food, in textile industry, pharmaceutical industry, cosmetic industry. And likewise, gum resins are used in perfumery, cosmetic, medicine, spices. If we come to production of these natural resins and gums, we see that total production on an average is about 2.8 lakh ton every year. And in this major chunk is coming from gums, and that is also especially from guar gum, which is mainly grown in Rajasthan, Gujarat, and Haryana. Then coming to production of different resins, lag is mainly produced in Jharkhand, Chhattisgarh, Madhya Pradesh, West Bengal, even in Maharashtra. Likewise, rosin, mainly it is in Hindi region, Uttaranchal, Himachal Pradesh, Damar, again in West Bengal, Assam and Jharkhand, and other resins are produced in Maharashtra, Madhya Pradesh, Gujarat. Then, as far as gums are concerned, what is used in, as I said earlier, Rajasthan, Gujarat, Haryana, Uttar Pradesh, karaya gum mainly in Madhya Pradesh, Odisha, Andhra Pradesh. Asafoetida, another important gum resin, which is produced in Jammu and Kashmir and northeastern states. And mostly we are importing Asafoetida from different countries, and value addition is taking place in our country, and either it is used for internal consumption or it is re-exported. Then gum arabic is produced in Rajasthan, Madhya Pradesh and Gujarat, and this is a very important gum, and there is a huge demand in our internal, for our internal consumption, able to meet the demand, and that is why India is importing gum arabic from African countries. And other natural resins, other gums like gum ghatti, Asian gums, etc., is produced in Madhya Pradesh, Chhattisgarh, and Maharashtra. If we see the export and import scenario of different natural resins and gums, it is a good source of foreign exchange earning, and Annually, we are earning a tune of about 3,000 to 4,000 crores of foreign exchange money by export of different natural resins and gums. Lac is one of the important resins exported. In gum category, guar gum is contributing maximum in export. As far as gum resins are concerned, we are importing them also, and then after value addition, we are re-exporting. So now coming to our main topic, that is LAC, on which we will be discussing on its mechanization for production and processing. So let us know something about LAC. What is LAC? It is produced by a specialized group of insect called LAC insect, and commercially LAC is exploited by lac insect Carya laca and Carya chinensis. And this we can see insect settle on the branches of tree and then take feed as a cell and then produces lac incrustation on the branches, which is scrapped by farmers and sold in the market. Major host tree on which lac is Katia monosperma, that is Pallas, Ziziphus mauritiana, that is Bear, and Celiacara oleosa, that is Kusum. These are major lac host trees, and our institute has identified Busi lac host tree, that is Phalemingia semellata, which can be raised in 1 year, and lac cultivation can be started. Otherwise, on these big trees, for raising new trees and taking lac cultivation take lot of time. Say for example, Pallas, not less than after 6-7 years of planting. In case of Bear, maybe after 5 years. In case of Kusum, it may take more than 10-15 years. So lac, what we get from farmer, contains 3 useful things, that is resin, dye, and wax. And what farmer sell is known as stick lac. It contains impurity to the tune of 30 to 40%, which is removed during primary processing, about which we will discuss. And in primary processing, impurity to the tune of say 30 to 35% are removed, and in next stage it is converted into seed lac, and this particular product, what we are seeing in the middle, contains about 3 to 5% impurity. And then if it is hot filtration of this is done and formed in form of thin sheet, then it is known as shellac, and this is considered to be purest form of lac. Then some important gum. The guar gum is one, mainly produced in India, Pakistan, Sudan, and a part of USA. And total production in India is about 850,000 metric ton, which is about 80% of world production. And it works as a good emulsifier, thickener, and stabilizer in food and cosmetic industries. Apart from that, it has got application in different areas. Then again, gum arabic, this is another important gum, edible gum, and used in food, pharmaceutical, textile, and chemical industry. And then gum karaya, again in gum karaya production, India is a leader, and its production is about 1,500 tons per year, and it is mostly used in pharmaceutical industry. Then Essa foetida, again it is another important gum and resin produced in India, also imported from other countries, value addition taking place in India, and again it is being exported. Then the role of natural resins and gums in national economy and livelihood support. As we discussed earlier, natural resins and gums earn foreign exchange to the tune of 3 to 4,000 crores of rupees for our nation. Then it supports 50 to 60 million population inhabiting in forest and sub-forest area. And then it is a good source of employment in the forest and sub-forest area. So considering the importance of natural resins and gums in the year 2007, mandate of Indian LAC Institute was enhanced from LAC to all natural resins and gums, and its name was renamed as Natural Indian Institute of Natural Resins and Gums. All natural resins and gums cannot be produced due to different climatic condition requirements for production of different natural resins and gums. That is why in 11th plan, when the mandate of institute was enhanced, one network project was also approved to this institute with 10 centers having objective, 5 objectives listed here, mainly on primary processing, standardization of then value addition, and then whatever technology is developed to be transferred in the specific regions. So with these 5 objectives, network project on harvesting, processing, and value addition of natural resins and gums is continuing with 10 centers. And we can see that different centers have been assigned a different activity or crop. Say, for example, II Energy Ranchi, that is Hello, my slide is visible now and sound is audible. Okay. I think up to this I have covered. You can confirm. This I have covered, this slide. Okay. This is also over. Okay, okay. So our network project center are located in different parts of country, and we have 10 centers in our network project working on different commodities like gum arabic, rosin, from pine, guar gum, gugal, gum karaya, tamarind seed gum, damar, and pinus cassia located at different places in our country. And 6 centers are in state agricultural universities, and 4 centers are there in ICR Institute. We can see here the location of different centers. Our centers are located throughout the country. In the north, we are having center at Solan. In the south, we are having center at Thrissur and Coimbatore. In east, we have center at Varapani. In west, we have center at Jodhpur, and in central India, we have center at Jhansi, Jabalpur, Raipur, Parvani, and Ranchi. So this was in brief introduction about natural resins and gums. Now we will discuss about mechanization of lag cultivation. First of all, we should know what are the cultivation operations being carried out in case of lag cultivation. Lag cultivation is somewhat different from crop cultivation. Here, as it is grown on trees, so most of the lag cultivation operations are to be carried out on trees, and few of them are carried out on ground levels. So we can see here, first of all, pruning of a host tree is done because lag is a tiny insect and it settles on branches of trees which are soft because these lag insects take feed from these branches by inserting its proboscis in the branches and taking cells up as a feed. So we should have lot of succulent branches on the trees. That is why pruning of a host tree is done. So that is a first operation in lag cultivation. Then similar to seed, here it is called brood lag. Brood lag is nothing but live lag insect which is emerging from mother cells of lag insect. At that stage, branches of lag sticks are cut and it is tied on the trees which has got a lot of succulent branches so that tiny lag insect come out of the seed, that is brood lag, and settle on the branches and starts its new life cycle. Then other is next operation in lag cultivation is used up brood lag removal. In no crop we get seed back. When we sow seed in the field, it remains in the field and plant grows out of it and then we get something. But in case of lag, when we tie brood lag bundle on the trees, lag insect come out of these brood and settle on the branches, whereas lag incrustation farmers get back. So if there is a failure of crop, then some part of money they are spending on purchasing brood, that is seed, they are getting back. So in hardly any crop we observe like that. So that is known as funky used of broodlac removal from the tree where it has been tried as a broodlac. Then likewise other crops, here also there is a problem of pests and enemy insect, so sometimes spraying is required. Then once the crop is mature, it is to be harvested, and these operations are to be carried out on tree. And once the crop is harvested, that is the branches having lac incrustation, mature lac incrustation is harvested, then it is either used as a seed or broodlac, or lac incrustation on that is removed and sold in the market by the farmers. So here we can see different lac cultivation operation being carried out. This is a picture showing the pruning of tree being carried out. All the branches are removed so that new branches come out, and on that lac insects are inoculated for next cycle. This is a brood lac selection, because leaves etc. are to be removed from the stick, and healthy brood is to be segregated out for using as a broodlac or seed. And this is a bundle making. They make a bundle of 2-3 sticks together, and for tying on the branches of tree, their succulent branches are available for settlement of lac insect. Then placement of broodlac bundle. Here we can see on a bushy lac host plant, broodlac bundle is tied. Then in case of bear, again it is tied on the branches, so that insect come out from these brood and settle on the new branches. Here also we can see, here we use some net, because if these nets are used, then enemy insect coming out of these broodlac doesn't go in next crop, because some enemy insect remains inside this brood, so that they are trapped in this polythene bag, net bag, and it is trapped, because enemy insect size is more in comparison to the lac insect coming out of the brood. Then this is a used up broodlac removal process. Whenever we tie bundle, once insect has come out, then it is to be removed. Otherwise, after emergence of lac insect, emergence of enemy insect starts. So timely removal of this used up broodlac, that is known as funky, is required. And once these funky or harvested crop is taken by the farmers, they sit in a group. Mostly it is done by ladies, scrapping. That is removal of lac incrustation from the branches. So like this, there are 5-6 operations involved in lac production. And this is a spraying operation as and when required. So there is a need, why we need mechanization. This is well known to all of us, but again to discuss, mainly to reduce the drudgery of human and animal in performing the operations, and then to perform the operations timely, and then to perform operation fast, and to reduce the operational cost. So these are main aims of mechanization. And in comparison to other crops, mechanization of lac production is a bit difficult, as we have seen earlier that most of the lac cultivation operations are to be carried out on the tree. It means people are required to climb on the tree and do the operations. Secondly, lac host trees are not on plantation basis. with the lac growers. It is scattered mainly, it is there in the field or on the boundaries or in the edge of a forest area. And terrain is also difficult. So it is difficult to carry out heavy equipment for mechanization of like cultivation operations. So we have to keep in mind these extremities in case of lag cultivation when we think of mechanizing different operations. So we have to have small tools, easy to carry and easy to operate, and at the same time it can be operated when people are climbing on the tree. So coming to the first operation, that is equipment for pruning of lag host, mainly three equipments are in use, that is a pruning knife, secateurs and tree pruner. So this is a pruning knife used by farmers, and this is a multi-purpose tool used for pruning of lag host, removal of used up brood lag, harvesting, and even for scrapping of lag. And usually it is about half a kg in weight, and it is locally manufactured by blacksmith. And then we are recommending use of roll cut secateurs for pruning, brood lag selection, and even for harvesting in case of lag cultivation. And many companies are making such type of secateurs, and this small tool has become very popular among the farmers involved in lag production. Then this is, we can see operation of this roll cut secateurs in selection of brood. And this is a very good tool, and sharp cut of the branches is obtained by this tool, and it is preferred. Then another important equipment for tree pruning is a tree pruner, again used for pruning of small lag host trees like bear and palas, where this equipment can be reached up to a height of say 10 to 12 feet if branches are to be pruned at this height. Now my sound is coming. Hello. Hello. Okay. Then I am seeing the PowerPoint. It is visible now. Okay. 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 Now I am connected with mobile. I think it should not be problem now. Okay. Then next operation is used up root lag removal. And in this, mostly this operation is being carried out by lag growers by climbing on the trees and then untying the bundle and then removing it. Alternatively, we have developed a small tool for removing of brood lag bundle. We have provided one cutting knife which can be engaged in the string with which bundle have been tied and pulled down, then it will cut the string and then bundle will fall and collected in a net provided in this small tool. So again, this tool can be reached up to a height of say 10-15 feet, depending upon what length of pipe we are using. And this can avoid climbing on trees for removal of used up brood lag. Then another important operation in lag cultivation is scrapping, and there are different scrappers which have been developed at our institute, and farmers prior to development of these scrappers used pruning knife for scrapping of the lag. So this is a small scraper, hand operated lag scraper developed at our institute. It has a capacity of scrapping about 6 kg per hour, and it can scrap incrustation from sticks up to 95%. And as a power source, one person can operate this machine. So this is a same machine, but here power is provided by paddling. That is a paddle operated version of this machine, and capacity remains the same and efficiency also remains the same. Then wherever there is a power available, we have also tried for a power operated scraper, and once it is operated by motor, then its capacity increases about 10 kg per hour, and efficiency again remains about 95%. And here we can use a single phase AC motor of 0.5 HP for operating this small machine. Then here we can see the performance of this machine. These are the sticks before passing this machine, and after passing this machine, we can see that most of the incrustation have been removed, and few are left, and that is about 5% remains on the stick, which can be manually removed. Then spraying also becomes sometimes essential to address the attack of enemy insect on lag crop. And as we have discussed earlier, the spraying is to be done on the trees, branches where lag insect has settled. So for that we require a sprayer, something like a rocker sprayer, which has got long hose so that machine can be operated on the ground, and person is spraying on the can climb on the tree and can spray. So rocker sprayer is suitable for tree host. Then this is another version of rocker sprayer. Then NAHEP-IDP sprayer is suitable for bushy like host plant, because in nowadays a lot of people are coming to raise bushy lac host plant. So for that, spraying knapsack sprayer is suitable and recommended. So these are a few addresses from which these small equipment like sprayers and tree pruner and secateurs, etc., already used in other agricultural or horticultural operation can be obtained. Otherwise, few equipments we have developed at our institute. We have transferred the technology to one manufacturer, and the manufacturer is selling those equipments and selling to the needy persons. So this was about the effort made or the status of mechanization in lac production. And now we will discuss a few things related to lac processing. And our focus will be on primary processing operations being carried out at either lac processing industry or exploring possibility of primary processing being carried out at village level, and effort made by our institute for developing a small machinery so that primary processing can take place at village level. So here we can see stick lac is the product sold by the lac grower in the market. So this contains about 30 to 40% impurity in terms of stick, stones, sand, insect body, and lac dye. So these are to be removed, and once these are removed, then we get the next product is known as seed lac. So this is how it looks like. This is a scrap lac. In this form, farmers sell the produce in the local markets. So once this primary processing is done, then we get something like this known as seed lac, because it appears in form of small particles looking something like a grain. So it is called seed lac. And this product contains, as we discussed earlier, there was some disturbance, some fabrication work is going on. So this is a flow chart for primary processing of lac. So what actually unit operations are carried out in primary processing of lac for removing impurity from 30-40% to about 3 to 5%. So first of all, the stick lac is crushed because each incrustation is composed of a spherical, hollow spherical cell of female lac insect. And one thing I wanted to tell at this point of time, I should have told earlier, that production of lac, mostly it is a contribution of a female insect, and male insect dies in the initial stage itself after fertilizing few female insects. So this female insect is in the form of a hollow sphere, and for washing and inside that hollow sphere, female insect body is there. So until and unless that hollow sphere is broken into pieces, it will not be exposed for washing. So that is a purpose of having crushing of stick lac into a mesh size of 8 to 10 mesh size, so that it is exposed for washing. And then after crushing, it is sieved using 8 to 10 mesh sieve, and whatever is remaining on that 8 to 10 mesh sieve is again resent for crushing. And 8 to 10 mesh size, particle size of less than 8 to 10 mesh size is sent for washing purpose. And aim of washing is to remove the dye, insect body and stick. And then once lac is washed, it contains about 30 to 40% moisture content. So it is centrifuged so that drying time takes in next unit operation, it takes less time in drying. So some of the industry are using centrifuge for removing excess moisture in washed lac. So once the lac is dried, then few wooden sticks, etc., still remains there. Sand and stone pieces, if it is there, it also remains. So that is removed while winnowing and cleaning operation. And once winnowing and cleaning operation is completed, then different size grains are graded. And bigger the size of grain, it fetches more price. So once it is graded in different forms, then we get a seed lac of different grades. So seed lac, again, it appears in mesh size of 10 or less, and its color varies from yellow to reddish brown, depending upon the host tree and place from which stick lac have been collected. And as we have discussed earlier, impurity in seed lac ranges from 3 to 8% and average is about 5%. And there is a market for this semi-refined product in foreign countries as well as in the country for making different value-added product out of the seed lac. Then we have seen in the flow chart itself the unit operation required to be carried out for primary processing of lac, that is a conversion of stick lac into seed lac. So crushing, washing, drying, winnowing and grading, these are 5 unit operations required for primary processing of lac. So lac crushing we have discussed just before, just few slides back. Idea behind crushing is to expose more surface area of lac cell for washing purpose, to remove insect body and lac dye present in it. And then care is, however, taken not to break up the cells too much, since in subsequent operation, that is washing, if particle size is very small, then it may go away along with the wash water. Then for this crushing, roller type of crusher, either operated by manually operated or power operated crushers are in use in lac industry. Then the next operation is washing. After crushing and sieving, lac is subjected to washing process to free it from water soluble dye. Yes. Yes. Hello, my sound is audible? Okay. This washing is required to free it from water-soluble dye, sugar, insect body, woody matter, and uncrusted lag cell. Again, washing is done either manually or mechanically in the industry. And there are different type of washing depending upon how much purity we want. So one is known as golden washing, and for washing aid in terms of soda or we can say washing powder, it is sometimes used, and sometimes multani mitti is also used as a washing aid in lag washing. So if soda is used at a rate of say 4.25 grams per kg stick lag, the impurity in final product reduces to 2% from 30 to 40%, and color also is very bright, appears like golden color. So that is why it's known as golden washing when we use soda at the rate of 4.25 grams. Similarly, 3% washing, it means impurity is less than 3%, and use of soda is at the rate of 2.5 gram per kg. Similarly, 5% washing, in use of soda is at the rate of 1 gram per kg, and impurity level in this product will be less than 5%. So these are some terminology used by lag processing industry for different type of washing. Washing, as we came to know that it is either done manually or mechanically. So in manual washing, stone vats or cement vats are used, having a diameter of say 75 centimeter and depth 75 centimeter. And a person with the help of his feet and hand rub the crust lag against the rough surface of the wall of stone or cement vat for removing impurity. And one person can wash up to 140 kg of crust lag in a day in this by this method. And here water requirement is about 7 to 10 liters per kg of crust lag. Then mechanical type of mechanical washing is followed in lag processing industries, and they are using cylindrical type of barrel washing machine, usually having a diameter of 1.2 meters and length 2.4 meters. And this size of barrel washing machine can accommodate 4 to 7.5 quintals of lag, crust lag in a batch. And agitators are provided inside the barrel so that it can agitate the material along with water mixed in it to remove the impurities. And one batch of operations takes place in about 1.5 to 3 hours. And water requirement in mechanical washing is more as compared to manual washing. Here 15 to 20 liters water per minute is to be supplied in the barrel washing. Continuously water is poured in the barrel, and the wash water is coming out. And once the clear water, means colorless water, starts coming from the outlet, we come to know that the washing has been completed and material is discharged. And usually to operate this size of barrel washing machine, diesel engine or electric motors are used. So this is a line diagram of the barrel washing machine. These are three outlet for wash water, and at the bottom we can say there is a outlet for discharge. And this is at the top there is a opening for feeding the material and water. Then coming to lac drying, generally lac industry use uh, uh, sunlight for drying, and it is generally done on cemented courtyard, and it is spread in very thin layer and turned over frequently, because melting point of lac is about 70 degrees, and it starts softening at about 50 degree or so. So continuous raking is required, otherwise lac start sticking to the surface. And sometimes if it is a summer season, drying is done in shade in comparison to in open sun. And then once it is dried, still all the impurities are not removed in lac washing. Some sand particle, stone particles, wooden particles still remains in the material. So those are removed by lac winnowing and cleaning. And once it is done, and these operations are mostly done in the eastern, even in the industry, manually, and generally done by the female workers. And one female worker can clean and grade up to 150 kg of seed lac every day. So these are some of the equipments in use in industry. This is a hand operated winnower, a line sketch of that, used in industry for winnowing the washed and dried seed lac. Then this is a list of equipment in use in different lac processing industries. For crushing, they are using crusher, either manually operated or power operated. For washing, they are either using stone vat or cement vat, or mechanical. In mechanical washing, they are using barrel washing machine operated by either diesel engine or electric motor. Then for drying, they are using sometimes centrifuge, and it is either dried in sun, mostly in winter season, and in summer season it is dry in shade. For winnowing, sometimes they are using hand operated winnower, or manually it is done by bamboo trays. Then for grading, they are using sieves, manually operated, and sometimes they are also using de-stoner and sand separating machine for cleaning and grading of the seed lac. So yield of seed lac again depend upon different factors. Host species is one. Judging of quality of lac depends upon impurity present on it and its color. Lighter is the color, better is lac. So lac coming out from kusum tree or kusmi lac insect is considered better because it is lighter in color and yield also is more. Then the next season of collection of stick lac, this factor also affects the yield, because in say rainy season crop contains lot of moisture, so finally yield reduces due to lot of moisture in it. Then type of stick such as ari means unmature lac, sometimes it is harvested. Sometimes farmer need money, so they harvest unmature lac and sell it. Or funky means it is used up root lac, almost dried. So if it is used up root lac, yield will be more. If it is ari containing lot of moisture, yield will be less. Then amount of impurity present in it, if impurity is more, yield will be less. Then method and extent of washing. Say if we use more washing agent like soda, then yield reduces, because in soda medium lac get dissolved and it goes away with wash water. So yield is reduced, but at the same time quality improves. If quality is a criteria, then we have to sacrifice some yield. So these are the parameters on which yield of seed depends. In a study carried out at our institute long back, these are the average yield of seed lag from stick lag for kusum tree lag, bear tree lag, and palas tree lag. And these are the names of crop, and mostly nomenclature is based on the month in which these crops are harvested. So there are two types of lac insect, kusmi lac insect and rangini lac insect. Kusmi being grown on kusum and bear tree, and rangini being grown on palas and bear tree. So bear becomes the common host for both of them. So Ghani and Jetli, these are the two crops for kusmi lac, and Baisakhi and Katki are the two crops for the rangini lac. And in case of Rangini lag, yield is less in comparison to Kusmi lag. We can see yield in Kusmi lag varies 68 to 69%, whereas in case of Rangini coming from Baisakhi and Katki crop, yield is less. It means impurity is more in this. So now some effort made at our institute for developing a small scale lag processing unit so that primary processing operation can take place at village level. Mostly this processing operation takes place in processing industry, and storage of stick lag, that is the produce of farmer, is a problem with the farmer, because proper storage require a lot of space, because these scrapped lag cannot be kept in a heap of more than 1 feet height, because once the height is more than due to pressure, it starts forming lump, and once lump is formed, quality deteriorates, and industry faces a lot of problems breaking the lump and in primary processing of lag. So mostly farmers just after harvest, either in need of cash or due to storage problem, they sell their produce at whatever price they get at the time of harvesting. So this was a problem. So our institute thought, why not have a small machinery so that primary processing operation can take place at village level, and villagers can convert stick lag into form of seed lag by primary processing, and seed lag can be stored in metal bin or in gunny bag like other grains. So with that idea, we have developed at this institute a small scale lag processing unit consisting of these 4 small machines. Actually, we have scaled down the machinery being used in lag processing industry for different unit operations. So this first is a lag crusher, then this is a lag washer, this is a lag winnower, and this is a lag grader. So these 2 machines like lag winnower and lag grader can also be used for winnowing and grading of different agricultural produce like wheat, paddy, even pulses, etc. Whereas in industry, these machines are mostly driven, bigger machines are there, driven by either diesel engine or electric motor. But we have here kept provision both. Either it can be driven by single phase electric motor, or it can be driven manually. Say, for example, this crusher can be operated manually. Barrel washing can be operated by paddling, that is paddle operated, and then winnower and grader can be again operated by hand cranking. So all the 4 machines, wherever power supply is there, electric supply is there, can be operated by a single phase electric motor. And if power is not there, it can be operated manually also. So as far as crusher is concerned, its capacity is about 15 kg per hour, and it can be driven by quarter HP single phase AC motor. And these machines are gender friendly, and only one person can operate this leg crusher. So this is a motor cum hand operated leg scraper cum crusher. So this machine can do both the operation because at village level they also require to scrap the leg, and then after scrapping it can be crushed for making it into seed leg. Then there is another machine for washing. So we have scaled down the size of barrel washing machine used in industry, and this machine can take a feed of 35 kg in a batch, and in a day 2 to 3 batch can be processed, and it can be operated by either 0.5 HP single phase electric motor, or by paddling it can be operated. And again this is a gender friendly machine. Here we can see in a commercial barrel washing machine their wash water outlet used to be 2-3, but here we have provided only one because it is a small in size, and it can be easily operated by a paddling. And if electricity is available, it can be operated alternatively by electric motor. And at the top there is a feeding hopper. Through this, crushed leg can be fed into the machine, and at the same time water is also continuously poured down. And when the machine is in operation, wash water along with impurity comes out of this outlet, and once washing is complete, that is confirmed when from this outlet colorless water starts coming out. So then next is lag grader. Like other grader, we have also developed a grader for grading crushed lag or washed lag. Only difference is there. We have here provided positive feeding type mechanism for this, so that whenever a machine is operating, we fill the hopper and there is no need of monitoring it. If machine operates, then it gets feed, otherwise feed is not going to the screens. And again, this grader can be operated by quarter HP single phase electric motor, and it can grade up to 60 kg of material per hour. This is a grader, simple grader, hand operated ones, and it can grade into 3 fractions because 2 sieves are there. This is a line sketch of the same. And then we can see here how grading has taken place into 3 grades. This is the raw material fed to the grader, and we get into 3 size grains after grading from this grader. Then lag winnower we have developed to separate out wooden particles or lighter material present in the washed lag, and this can again be operated either manually or with the help of quarter HP single phase electric motor. And this has got a large capacity. It can winnow up to say 500 kg of material in an hour. Again, this is the line diagram of the same. So these are the 4 machines costing about 5 lakh rupees. And if we construct a small shed for a small scale lag processing unit, it may cost around 5 lakh. And operating cost for 3 months in terms of having raw material, because raw material here comes costly around 200 to 300 rupees per kg. So for that, working capital of about 8 lakh is required. And to operate such type of unit, if it is a manual unit, 5 persons can operate it. And if it is a power operated unit, 3 persons can operate it. And inputs, daily inputs in terms of say washing agent 0.5 kg per day, water requirement about 2,500 per